Folks, are you all ready today? Yeah, started with everybody. Let's amazing. Okay, hello Sri. It's okay. Yeah, Jarvis seems fully charged for the session. Hi, hello Asta. I can see many folks coming in there. Good to go. So yeah. So today what we are going to do is we are going to build a project and we are having today a bonus for you all, right? So do you want to know regarding the bonus? Yeah, Shri, but it's all about learning. Maybe if possible, we will have more such boot camps related to deep learning and all. So no need to worry regarding that. And I keep on taking sessions, and Chetan and other speakers also keep on doing that. So not for machine learning specifically, but you can also join other sessions there, right? So without wasting our time, let's move further. So what we are going to look today is a amazing project which would take yourself to the childhood that was watching animes. The one was Pokemon classification, right? So we talked on the one day. We talked about it on the one day, right? On day one. So let me know what was this about? Like what was that example? Pokemon classification one. Like Pikachu want to know that. Okay. Yeah, Kapil, you will be sharing with you. Just do a thing that go to LinkedIn and keep the notification on from my side. So whenever a event will be there, I keep on posting on there, or other folks they keep on posting there. So yeah, you will got to know that if any of the such event is lined up, right? So yeah, let me know what you did on the day one. I guess it was an amazing project, I guess, right? So yeah, I'm waiting for that. Can I just know in the chat box? Okay, can see few folks typing in, just waiting for you guys. Like, yeah, just tell me. Mapping function. Okay, sounds a little strange. Can I just know like what exactly you want to say? I guess we covered something like mapping function. Mm-hmm. Um, yeah. I one of my friend will surely drop the LinkedIn link in the chat box, so you will get that ask. It's completely fine. Yeah, without wasting time, let's move further. No need to worry if you are not able to get that what we saw on the day one. On day one, we saw an amazing project that was Pokemon classification, right? To understand what was supervised and unsupervised. So we are going to build it today. We will be having an data set of three Pokemons. They are Pikachu, Bulbasaur, and Charmander. So if you don't watch anime or you haven't gone through Pokemon, so no need to worry. Just imagine these are some characters. His name is Pikachu, and there are two more characters whose name is Charmander and Bulbasaur. Right. So if there are new program, kindly let us know in advance so that we can disseminate it and the good news to our other platforms and bring it. Yeah, sure, Cap. We will do that, and it will be good if you share it because we just do it to reach more folks and learn from them. The same you do, you learn from us, right? So this peer-to-peer teaching should be there. It's a good practice. I learned a lot from these sessions only. So yeah, let's move further. So towards before we move towards Pokemon classification, so what we are going to use today is a neural network. Like till now you heard regarding machine learning, but just to give a small understanding of what deep learning is, we have kept this today's session. So for building this amazing project that is Pokemon classification, we are going to use deep learning. So can anyone just tell me what is deep learning? Don't no, I don't no need to worry. Like whenever you see this strange image, now like why we are learning bio. So this things comes to our mind first, and same is the case with me. So no need to worry regarding that. Like I will clarify that what this neuron is doing, which is actually present in a body. Not a neuron. There are millions of neuron you can say. So just a briefing regarding deep learning. There are different layers. Yeah, yes, you are going somewhere right. Okay, it consists of artificial neural networks. Okay, Janvi seems like she's a machine learning folk, and Yash also. So okay, fine. And anybody who has not heard regarding it and want to try something, you can go for it. Just try to open up yourself and try to put something in the chat box. It's fine if it's wrong. Like no one is going to scold you because I'm not your teacher or a professor or a faculty which used to scold you when you were a kid or a student. So there's nothing like that. I'm one of your friend. So what we are doing is peer-to-peer learning, right? Okay. Yeah. So let's move further. I don't I think few folks are typing, but let's move further. So what is this? This is a neuron which we have in our body. It is also known as a biological neuron. So before we move further to understand what is this neuron, so I guess Vaidehi Vaishnav don't have the access to the chats just because she has logged in with an unknown mail or she haven't signed it up, right? So please do it if possible. If you want to type something in chat box. Yeah, it's about networking of neurons. Great. So what I will know is this is a small neuron which is already present in our body, and you must have heard something like stimulus, right? So whenever you try to touch a hot pan or a hot boiling water, your brain just pull off your hand, right? It don't allow you to touch the hot water. Why so? Just because there are some sensors in your skin and this sensor sends and some data to the brain. But the question is how this sensor send the data from your hand to your brain. Isn't it amazing? So that stuff is done by neurons. Yes, it is neuron. And what it does is, so these are the dendrites, and this dendrites take some electrical impulses and they just pass on these electrical impulses to through these axon terminals. It is also known as synapses, right? So just a typical neuron body, you can say, and this is just a single neuron, guys. From your hand to your brain, there may be billions or more than that amount of neurons already present in our body. So how many of you are just thinking that why it is relating to our deep learning portion, right? So yeah, the answer for that is, so what computer scientists looked over was they just tried to mimic this thing. They just try to put this thing in a model or in deep learning, we call it deep learning, and try to make something similar and make a model understand over a data, to learn over a data, right? So from the first step, what we did was we looked over many machine learning algorithms. There were many, right? And so that machine learning algorithms, what were they doing? They were just learning on the given set of data, isn't it? Right? So they were just learning on the given set of data. So same thing we are going to do in this deep learning also. But the only new thing we are going to look is deep learning is a new approach to learn over a data, and that new approach involves neural networks. What is this neural networks? So neural means one neuron, and network means network of neurons. The same way our body has, right? So yeah, so let's try to understand how we are going to mimic this. So we saw that this was an example of a normal neuron, biological neuron, we can say. And this is an artificial neuron, which we will try to make. So yeah, let's dive deep and try to understand what is this. So you may just imagine the synapses as the output, this dendrites as the input, and the cell body as the neuron. Like like it is completely a neuron, but you may say the cell body. Like this entire thing is stuffed together, a activation function and a artificial neuron. Neurons body, you may say cell body, you may say cell body, and activation function are grouped in together. Okay, it okay. Can I know something in chat box? Like, is it going too fast, too slow, or you all are getting? It's completely fine. Like this is the entire biological stuff, and yeah, great. So the thing is, I biology was my favorite subject when I was in my 10 plus 2 grade and 10th grade. So yeah, I actually love that it's helping somewhere to understand deep learning. Great. So the thing is, we try to understand that uh, this is something we try to mimic, right? So let's dive a little deeper and try to understand that what are these dendrites, like what are these inputs, what is this artificial neuron, what is this activation function, and what is this output, right? So let's move further and check it out. Okay, this seems little strange. Yeah. So just imagine, guys, these are some inputs. Like this L1, L2, L3, and L4 are some inputs, right? I will tell you with a real life example, so it will be quite easier for you to understand. So just imagine that this input one is x1, input two is x2, input three is x3, and input four is x4. So how you will add up all? So just a simple answer, summation of xi. And this I stands for 1, 2, 3, 4 till n, till number of inputs, right? So hope you got this, what I want to say here, because it was not possible for me to write it with my stylus and all. That's why I just kept it already written. And the next thing is these are the weights. I will explain you why these weights and what are these weights actually doing. No need to worry. Just imagine there are certain weights assigned with these inputs. What does this weight say? This weight just tell you that this input has something around 0.6 weightage to get the output. For example, okay, so let's see the example in next slide, right? So hope you got this. What is weight one, weight two, weight three, weight four? This is something which tells that how much effect will this input make on the output, right? So it will be a probability between 0 to 1, you may say, these weights. So yeah, when you sum up this entire thing, so it will be summation of xi wi. Wi stands for weight 1, weight 2, weight 3 till number of n inputs, and similar to x1, x2 till number of x and inputs, right? Hope you got a small briefing. It's completely fine if you are not getting the stuff. When we will, yeah, let's move towards a example only, right? So you may imagine it like this. I hope you got till this portion entirely that what is happening here. Like what is this cell doing? You may call it a nucleus or a cell body. It is just doing xj, wj. In our case, it was xi, wi, right? And what was this I was still 1 to n. N is number of inputs. So just imagine, folks, like what example should we take? Um, okay, so just imagine that there is an e-commerce site by Microsoft, or you may say any of the product where they want to include something. So they just want to predict something. You may say that Microsoft want to predict that what this person will purchase after 1 month, right? It is an example of machine learning. We are doing some predictions on the given data. Now Microsoft has the data that in recent 3 months he has ordered some XYZ stuff, right? So what can be this input? This input may be, does the person has a valid subscription which will give the access for him to purchase in the cells? Or maybe this X1 may be like like how many spending he has done in the last month, and what is his average spending in the all months. Like if the average spending is done, then he's not going to purchase anything in the current month, right? So this x1 may be that input, or x1 may be any another input, something like whether he likes this or not, like whether this product is suitable for him or not. Maybe it is possible that his shoe size are somewhere around 11, and the product which he is looking for is with shoe size 9. So don't you think so that he's not going to purchase that? Okay, great. So let's try to understand that there is Microsoft's e-commerce site, something similar to Amazon, or we can take the example of Amazon, right? So this e-commerce site, what they want to do is they want to just predict that what is the probability of a person to purchase this thing in the next month. This thing may be anything, right? Let's take anything. Fine. So what will be the inputs for that model? Like what will the inputs? Inputs will be the previous data. What can be the previous data? The first thing may be that maybe it is possible that the product, like his is spending some xyz amount, something 5,000 rupees or $500 every month, and in this month he has done with $500. Still 5 days are remaining, so the probability of purchasing something new from the e-commerce site is completely zero, right? So this may be one input. Similar to that, one input may be whether he likes the color. Like maybe it is possible that in the previous data, the e-commerce site has the color selection sort of thing also, that they knows that what color he likes, right? So it is possible. It is also possible that he want to purchase the shoes, but the shoe size which is in front of him is actually somewhere around 11, and what shoe size he need is 9. So will he purchase that? Obviously no, right? So these are X1. These are the inputs. Like inputs may be many things. Now, what are these weights? The example I took as an input was shoes size. Like that may be one of the feature of to predict that whether this person will purchase the shoes or not. But the what will be the weight is the weight with the shoes input will be the number? Because if the number is 9, then it is definitely going to be getting to be purchased by this person. Don't you think so? Like, have you got that? What is this weight doing out here? Weight is just the probability that how much it will affect on the output. Like, it will be the weight. Like, weight of purchasing these shoes for this input is 0.7. When person is going to purchase this, if it is 0.1, then he will not purchase it. He will have to look for another inputs. Right. So hope you got a small intuition. What are these weights assigned with each and every input? Right. So this is a cell body. And what is this activation function? Yeah, a big question. So you may say there are three activation functions. One is ReLU, one is sigmoid, and one is tanh. What they do is they just try to compare the things. No need to worry regarding this activation function. Now, when we will move towards the programming portion, Chaitanya will clear it. And he will use a softmax function, which is quite similar to sigmoid, right? So this is ReLU, sigmoid, and tanh. There are only three functions as of now, and these three functions are to be used out here in the activation function, and then you get some output, right? For five inputs, for five features, you get some output. So this is just a single neuron, guys. This is just a single neuron. Okay, you mean input is condition and weight is probability? Yeah, you may say like that, Asta. Like weight is something which is assigned to the input. Like for example, what example we took? Yeah, shoes. For example, to purchase the shoes, there are n number of inputs, and from that one input is size. So if the size is 9, so the person, like the owner, like who want to purchase something, the customer size is 9, and the product is shown is also of size 9. So definitely it is having a chance to get purchased. Don't you think so? So have you got what is this weight? Weight is the probability. Like it, we may say that if we scale up into 0 to 1, so 0.8 may be the chance of the input size to get to make some effect on the output Y. Just a simple briefing. Like once you move towards the actual programming portion, you will get the things. So this was just entirely mathematical stuff. You might get somewhere confused, but it's completely fine. It happens when you go it for the first time, right? So we tried to understand just for a single neuron, right? But what if I say that there are not single neuron, there are millions of neuron or billions of neuron? So yeah, the same thing which we saw in a biological nervous system, like there may be many layers. So this is a input layer. These are some hidden layers, and this is the output layer. Now you might got a little confused that what I'm gonna say by saying this hidden layer. So just imagine, guys, this small circle is just an example of a neuron. Like there are two inputs, so two neuron. From these, there are four neurons. Like from this, a weight will go here, a weight will go here, here, and here. Like it will be assigned to all the four neurons, right? And what this portion will do, this hidden layer will do, they will try to learn a weight, they will try to learn something, they will try to understand that whether this user is going to purchase anything or something from a site in the next month or in recent 2 to 3 days. So this entire thing is going to be done by hidden layer, and this hidden layer consists of n number of neurons. Like you have to assign with your own that how many neurons will be there. So when you just imagine that if a small input is given to a single neuron, it tries to compute something. If it is computing something, it will require some computational power, right? We live in a world of technology, so obviously it is going to require some computational power, right? So similarly, like a single neuron, each and every neuron will have some computational power. So whenever you work with deep learning and there are n number of neurons, it actually require a high level of computation power. So mostly you may say it is not possible to predict something when the input is too large in our own personal computer. That's why we deal with something like virtual machines. Virtual machines, okay, don't need to worry regarding virtual machines. We use something like which is not our own computer because requires high computation power. High computation power means it will require large amount of RAM. It will require good processors, something like GPU and TPU. So there comes to the picture the entire computation power. Hope you must have got that why each and everyone says that you require a good computation power to run a deep learning model. Have you got that? Let me know in the chat box. Might be the things are going little confusing, but I assume that you got this simple thing that why it is going to require high computational power. It sounds really good, but I want to know it from other folks also. Like it is our last day, guys. Just let the chat box like flowing, right? So yeah, sounds pretty well. So you must be thinking that here lots of maths was involved. Something like this WJ, like summation, and then you will calculate this. I hope you must have done your maths 2 or maths 3 portion in your first and second year, or else you must have learned in 12th grade regarding integration and derivation. So hope you must have got that why maths was important at that movement. So you must be thinking that do we need to learn maths? So no need to worry, like you are not going to work in deep. You actually have this entire stuff programmed. You just have to import this from a given library. Like not sklearn this time, maybe TensorFlow or PyTorch. So you may just import that, import a neural network from that libraries. Hope you got it, guys. Like I will also tell you that how to deal with the computation power. Like as we said that it requires a large amount of computation power, isn't it? So I will tell you how to deal with that. We have good amount of resources available in the market. So the question may be arising in your mind is like how you are going to build the model using deep learning. Like you are given a data set of images in that they are labeled that Pikachu images are Pikachu, Charmander images are Charmander, and what was the third one? Bulbasaur, right? So Bulbasaur images are Bulbasaur. So how you are going to pass these images to the model and how the model is going to predict what is the given image, whether it is a Bulbasaur, whether it is a Pikachu, or whether it is a Charmander. So this must be a query for you all, guys. Let me know in the chat box if that's the query. I think the model is quite too big and we are going to require some amount of time. So yeah, we'll move further. Let me know in the chat box. Like I want to see you guys just typing in. It tells me that you are active, you are learning something, or else I just keep on thinking that you all guys are not actually getting me what I want to say. So that may have a negative impact. Like you should get if you are attending a session like this, you should get what I want to tell you. Right. So yeah, let's move further to know how to build the model. Talking about building the model, what we'll do is we need to just keep in mind that whenever we are building a model, you need to visualize the data set. That what is the data set, whether there are some CSV, there is some CSV file like comma separated values or a tab separated values, or there is an image file or there is a video file, right? Guys, you just must be thinking that there may be some possibilities like data set is little strange to you, like you haven't worked ever on a video data set, right? So from the starting of the session, we tried to handle a CSV data set, we tried to handle a tabular tab separated values dataset, and now we are also going to deal with image dataset. We also worked on an image dataset, I guess, right, for color extraction. So yeah, the first step would be to visualize your dataset. Now the next thing is, as we said, that whenever we build a model, we just have to pass a number to it, right? So what we will do, we will convert our image data into a number like we did in our color extraction process. Like we were given an image of rows into column into three. Three was standing for R, G, and B, right? So what we did was we just calculated. For example, there are 1000 rows, 1000 columns, and 3 RGB. So 1000 into 1000 into 3. Basically, you may say 30,000 or 3000, whatever it is, right? 30,000, right? So we were just flattening the image and converting into a single digital value. Where we're doing that using NP, that is NumPy. So similar type of thing we are going to do today. And whenever you work with the image dataset, you are going to do the same. So just keep in the mind like you are going to do the same. And whenever you work on any of the machine learning model, just keep in mind that your model is going to be same. Maybe there is any dataset, but what the things will change are the things are something like data pre-processing, like the way you process the data completely makes sense. Completely should make sense, right? If you have completely or wrongly processed your data, like you haven't passed it a flattened image, then it's obvious that your model will not predict the right answer. It's more obvious. So data processing is the key. You may say that like data processing is the only key feature of learning machine learning, right? If your data is good, your model will be good. If your data is not good or is not properly pre-processed, your model will never predict the right value, right? So yeah, then what we will do is decide the hidden layer and function. Like here we saw there are three functions. So which function to use? We need to understand this now. So for this, we will have to understand what function to use. And the next thing was we will also have to decide how many hidden layers we will keep. Like here are only two hidden layers, but what if we keep just one? It will work. It will work completely fine if there's single hidden layer. And we have to decide that how many hidden layers should be there. So yeah, hope you got it. But we can always pre-process the data according to our requirements. Yeah, that's what I want to say, Janvi. Ki whatever the data is, you have to pre-process as per your need. And to pre-process that, it is more obvious that you will have to look that how your data looks, like whether it is a image data, whether it is a CSV data, whether it is a video data. You will have to go through it once now. Hope you all are getting, like, it's completely simple things, no rocket science involved, and straightforward things, whichever I'm telling to you. What would be the ideal hidden layer one can use in a model? Like, you want to say number of hidden layers, Kavve? Or you want to say something like how many number of hidden layers should be there? Something like this, or what else? So a common answer for this would be more number of hidden layers, more accurate the model will be. Right. So there are a few more things. Now, we are not going to move in deep because this is our machine learning session. This is not our deep learning session, right? So in that, lot many things comes to picture. Like you may say something like what do you call it? Back propagation comes to picture. You see neural networks, LSTM, long short-term memory. So there are many things. A perceptron comes to picture, then a neuron comes to picture, then collection of neurons comes to picture. So it is a way too big field. So we will need to have a one more bootcamp for that. Yeah, how we decide the number of layers. So yes, it's completely up to you how many layers you have to keep. More number of layers, more accurate the model will be because it is going through more computation power. Have you got it? More the layer, more computation power will be required. Is the thing. If you have the resources, go for it. I will tell you where you can find these resources. No need to worry. Like we will just check it now. Yeah, it's been too late. Hopefully we should continue. So yeah, we saw how to do this, why to flatten, why to decide whether how many hidden layers and what type of functions to use. And the next thing is what we'll pass. We'll pass the array, right? We will pass the array now. This array will be converted into a single digit, like 1,000 rows into 1,000 columns into 3 RGB, 3, right? 30,000, isn't it? So these are our few steps that we are going to look while building the model. And yeah, let's move further. So yeah, there's a question for you all. Do you know who is Squirtle? Anybody who has watched Pokemon? Who know what is Squirtle? And can you answer this question? Okay, so the way there was Pikachu, Charmander, and Bulbasaur, there is one more Pokemon enemy that is Squirtle. Hope you got it. Like, what is Squirtle? So can you just tell me why Squirtle was saying this that our model can't recognize him? Can you just tell why so? Okay, nobody wanna answer it. Like, guys, I said each and every answer is in the data set. Have you heard that properly? Can't see any of the folk typing. Do you need me to answer? Like, because we are already running late for 10 minutes. So yeah, let me answer. So how can our model predict a Squirtle? Because we haven't given the data set to him. We just have given three Pokemon's data set, a Pikachu, a Bulbasaur, and Charmander. So where the Squirtle comes to picture. That's why Squirtle is saying that your model can't recognize me. Simple. That's the answer for him. Like why we can't predict whether it is a Squirtle or not. Obviously, it's common. Like we don't know how a Squirtle looks. We will have to tell our model, like how a Squirtle looks. Then only we will be able to predict that this is the Squirtle. We need to train the data. Like entire machine learning depends on the previous data. Like sometime, somewhere, you must have typed something. You must have given a textual data. That's why ChatGPT is working today. And have you got why ChatGPT is working too amazing today? Because you only created the data. You only gave the data. So basically, you may say that whichever social media platform is that there, if you are giving the data to him, he's going to predict something regarding you, right? So yeah, let's move further. So this was all, and I think we should move towards the programming portion. Before that, just a simple thing. As I said that, guys, we need a strong computation power, right? So for this purpose, we have an amazing resource that is Azure ML Studio. So yeah, It is by Azure Cloud, that is Microsoft Azure Machine Learning Studio. Yeah, someone is excited for programming. Just a simple bonus point for you. So if you want to train a large level of models, like bigger models which require a higher computational power, you may use this Azure notebooks. So to use that, just go to Azure ML Studio, open the first link, and just pick the account. And once you open that, then you will be directed somewhere around. Yeah, hopefully we are somewhere on the right path. Okay. And yeah, so what you can do here is web classification, bring your own data. Yeah, so this is just a quick guide for you, like how to start. So it's up to you guys. Like if you want to start from here, you can start, or else what you can do is you can create a new notebook. Just create a new notebook. Name this notebook as what we can name this notebook. Basically, you may name this file as a machine learning bootcamp or anything. Don't do it. Do it after me, guys. I will tell you. You are going to face issues while doing this. So as of now, just keep on watching what I want to do because we are going to program on Google Colab only, right? So we can keep it machine learning bootcamp or anything like learning. It's fine. So yeah, and file type will be notebook and overwrite. No need to overwrite. Yeah, just go for it and create it for me. So Azure says, okay, fine, I will help you out. And yeah, Azure did it for me. So okay, so this was a few project which I was working on. Like no need to. Yeah. So some you may say something similar type of interface, the one which you had for Google Colab, right? So okay, what I did something. Okay, let me check. Like, have we moved somewhere on different path? Yeah, like what I'm doing out here is which was my workspace. Inside my workspace, there was. Okay, no need to worry. Like, I guess I just refreshed it, so it just has vanished away. So let's create a new notebook, or you can see your recently viewed notebook. You can just open it up if you wanna open it. So yeah, something similar to this, you may see an interface. Now the thing arises is how to give it a computational power, right? So for that, just move on here. And once you move on here, move to compute section. And inside that, have a new compute. So once you are in the new compute, so you can see the options here, something like CPU and GPU. So yeah, it charges you guys. Like in starting, you will get $100 for free, but then it will be charged for you, right? So because it's an enterprise, so it is a paid service. It's not an unpaid service. And this is mostly used for each and every industry, you may say. So we'll have a standard compute, or else we can have a GPU compute also. Like the one I'm getting out here is, yeah, as of now, let's have a simple CPU compute. In that, I will have 6 cores. 1 to 10 GB is quite fine, and 4 cores, okay. Yeah, so we will have this 28 GB RAM and 56 GB storage. If you want more, you can go for it. Like there are many options available, like select from all options. Once you move on here and you just select CPU or GPU, like you see, you may get many options available out here, right? So there is an NVIDIA, Tesla, and all, each and every stuff is available. So just for knowledge purpose, it's all up to you. And we will have some standard one, like something like we'll have 4 core, 16 GB RAM and 100 GB storage. And hopefully, yeah, you may select it like this and use it. Like I'm not gonna do this now because okay, let's show you guys. So we can keep the compute name as bootcamp. Yeah. So yeah, once you select the compute standard, it can be anything as per your requirements. Just create this. Once you create this, yeah, it will. Okay, is it active? Hopefully it is creating. Yeah, it takes a little time because it is connecting to you, sir, to you for, like it is connecting you to a really unbelievable power, right? Amazing compute power. It will be just too fast. It will run in fraction of seconds, like more faster than Google Colab also, right? So yeah, hope you all guys got what is notebook and why we use it. Like I'm not gonna show more things out here. Like if you want, okay, let's show it. Like if you want, let's select a compute and yeah, like it is only creating. So you may get a notification somewhere around here whenever new compute. Okay, this is not the one. Notification is this one, guys. So be aware here. So you will get notification once the compute is done, and you will just have to turn this compute on, and it takes a little time. Then you can simply just write the code the similar way you are writing, like hello. enthusiast or hello MLSA, something like this. It's completely fine and you may use that. Have you all guys got what I want to say? And do you want to move towards the actual programming portion now? Please let me know, guys. Yeah, anybody in the chat box? Or am I not able to see? Great. So yeah, we will not turn it on right now, and we will move towards our question. And the further session is going to be continued by Chaitanya. So I request Chaitanya to please proceed if you are there with the actual programming stuff. We will have to digest it with time. Yeah, it's good.
Hello.
I will do that. Okay. Hi, hello Chaitanya. You may proceed.
Oh, thank you, Atharva. Am I audible clearly?
Yes, yes, you are clearly audible.
Okay. Just a second. Let me just share my screen. So, hello everyone. Can you see the screen? Okay, Siri can see it. Janvi is here. Kabwe is here. Priyanshu is here. Where are the others? There are, I guess, 10 folks more. Where are you guys? Okay, Asta is here. Surya Teja. Okay, that's a new name for me. Anyone else typing? So I can see that some people are typing there. So I guess we are running late. So I'll just start. So I guess Atharva told you that there are three type of activation functions, and there are some of the calculations required here. So I'm going to repeat the question that I asked in my first session. Do you guys remember the equation of a straight line? What is the equation of a straight line? Can you guys type in the chat box? Okay, Yash is quite fast out there. Great, Yash. Okay. What about the others? Sri, you are wrong actually. It's MX plus C. Everyone else, can you just type in the chat box? Okay, Surya Teja is here. Asha is also here. Janvi is also here. Oh, it's all right. It's all right. Okay, Cabby is also here. I guess Bonto didn't join today. Okay, so uh, you guys very well remember it, and what what Atharva was saying that these weights and biases need some computation. So what these each neuron is doing is that it is computing this y is equals to mx plus c equation around here. It computes y is equals to mx plus c for here, where the equation becomes y is equals to wx plus b. So did you guys get it what this neuron is trying to do? And by applying activation function, we want to limit the output of the neuron between 0 or some value. So sigmoid what it will do, for sigmoid we know that the graph is like this. So sigmoid what it will do, so for a given value, it will give only output 0 or minus 1 and 1. At the same time, ReLU what it will do, it will give the value between 0 and some positive value. And what tanh will do, it will just print values between -1 and 0. So did you guys get it? What are activation function and what are these neurons doing? What are the computations they are doing? At deep learning, at its core, it uses statistics and machine learning. So hope you got the intuition what uh, neuron network is trying to compute. Did you guys get it? Okay, Sri got it. What about everyone else? Guys, can you just quickly acknowledge me that you got it? Okay, so if you have any questions, you can ask. I'm ready to answer, even if it's not related to this bootcamp. Okay, so let's get to the coding part. So, what should we do, guys, first? Do you guys remember what is the first step we do? We always follow. Just type in the chat box. Okay, I wanna hear from you guys. No, no, no. We first sync our GitHub profile, right? So go to your GitHub, open your GitHub and search for your machine learning bootcamp lab repository. Yes, Cap we got it right. First we go to GitHub and we sync our fork. I guess I'm 9 commits behind. That's great. Okay, Cabby remembers it quite well. So guys, go to your GitHub repository and update your branch. Okay, okay. That's great, Cabby. That's great. So guys, quickly acknowledge me that you guys have synced your fork with the on the GitHub. Can you get can I get a quick acknowledgement from everyone? Okay, so I do remember the names. Those who acknowledge me in the start. I'm gonna call you guys. Hello, am I audible? Or you guys just syncing the fork? Okay, Yash is done. Janvi did it. Sri did it. Okay, so I guess Cabway, Asta, and Pushkar was there, right? And Surya Teja. Okay, Priyanshu. No problem. Okay, Asta, what will have you joined the WhatsApp group? Oh, that's great, Cabway. That's great. Okay, so Sri, thank you for that. So Asta, what we will reshare the link to the repository. So make sure you create one GitHub account. It's very important in our technical field. Make sure you create one and just fork that repo so that you can also contribute in on that. So guys, let's just move to coding part. I guess we'll all open Colab. Okay, Asta, for now, what you can do is you can open a normal Colab. Okay, just search for Google Colab. Search for Google Colab and open the first link you see. So I'm going to open it and I'm also going to zoom in a little bit. So guys, can you see the screen? And I hope everything is clearly visible. Chavez says yes. I can see the enthusiasm. Sorry for the pronunciation mistake. And there we go. We have our machine learning bootcamp repository. And we are in the week 4, day 2, Pokemon classification. Okay. Open the Pokemon classification, not your name file. Open Pokemon classification. So I guess it will take some time. Okay, great. So guys, quickly acknowledge me that you have opened the collab and opened the right file. What and for those who don't have the GitHub account, I'll just paste this code in the chat box so that you can just copy from here. I guess Asta didn't have the account. And so so I think we are good to go, right? Uh, yeah. Connect your runtime. I guess it will take some time. Okay, great. It got connected and run these first four cells that are already given there. And I'll tell you what each of these cell is doing. But oh shit, I'll clear this output because it's not helpful for me. So guys, quickly acknowledge me that you have ran all of these four cells. Okay, Cabrio says they are still running. So okay, so until then, I'll just tell what are these four cells doing. So first, we are importing our machine learning libraries, right? NumPy, Pandas, and Matplotlib, and also our operating system OS. Then, in this cell, we are downloading our dataset from this URL, and we are saving it with a name data. Okay, Cabris is done. And in this third cell, we are unzipping. So the dataset we downloaded was a zip file. So, and we are going to unzip it using the terminal command unzip. And in the next cell, we are installing this library, Keras preprocessing. Actually, it's a deprecated one. Don't use it for further, but we are using it because it just gives some computational power for us virtually, right? So firstly, what we want to do is we want to extract our classes from the dataset. So if you want to see how is your dataset, how does your dataset look like? So go to here, click here, and you'll see images folder here. And you can open one of these folder, test and train. This image folder contains our data set. So if you see the train directory, you will see there are three folders, Bulbasaur, Charmander, and Pikachu. And if you open those, okay, so we can see that there are some images, JPEG images. These images are of Pikachu. I guess it will show right here. Okay, so great. So what we want to do is we want to extract these names from our directory, right? So these names basically act as our class, what classes. So Bulbasaur is our class, Charmander is our class, and Pikachu is also our class, right? So what we want to do is we want to extract our classes. So let's ask Python to extract it for us, and we are going to use OS library for it. So hey Python, just extract those classes from me. I'll write the code for it. Classes equals to os dot list directory. And what I from where do I want to open these directories? So I guess these are, I guess, images and then capital train. Okay, so and I hope that okay, great. So okay, great. So you can see that we uh, what we got, we got our classes. We fruitfully extracted our classes from our data set. So we have three classes, right? Charmander, Pikachu, and Bulbasaur. I'll provide this code in the chat box so that you guys can also code along with me. Now, as we are doing some visualization or data set, we want to see how many images are there in our data set. So what we'll do for Pokemon type, right? Pokemon type in classes, right? So this is a for loop, and Pokemon type means that it will iterate on each class, right? Charmander, Pikachu, and Bulbasaur. So first, suppose that our first value is Charmander. So for Charmander in this class, in this whole list, for Charmander, what I want to do is I want to get a path which is equals to images slash 10 plus our Pokemon type. So for Charmander in our list, so for Charmander in our list, what I want to do is I want to get the path of the class, right? So in this first line of the loop, what we are going to do is we are going to get this path generated by our Python code, and what I want to do is I want to print the Pokemon type, right? So Pokemon type and also the number of images in it. So was dot list directory, sorry, dir, and it should be path. So if you guys are getting confused, don't worry about it. You can just check for the OS library documentation, and I guess it okay. Oh, I forgot to add a slash over here. Right. So we have 102 images for Charmander, 101 images for Pikachu, and 101 images for Bulbasaur. And I'll just quickly provide this code in the chat box. Guys, did you got it till here? Hey everyone. Oh, ooh. No problem, Bontu. You can continue from here. Can you open the collab? Just go firstly go to your GitHub, sync your code, and I guess you remember the rest, right? As soon as you open the collab, please acknowledge me. Uh, it's week 4, day 2, Pokemon classification. I'll pin the message so that you can see it. Sri wrote it for us. So I've pinned the message. Rest of the geeks, are you guys there? I hope you are following me there. Okay. Janvi is here. Cabri is here. Priyanshu is here. Sri is here. Okay, great, great. Okay. Surya Tej is also here. So I guess what should I pronounce your name? Should I pronounce it only Surya or it should I pronounce only Teja? Okay, so okay, Surya. Okay, great. So we got a number of images in our training data set, but what about the testing data set? So what we should do is you should be a good software developer and just copy paste the code and uh, just change something and say that it's completely mine. I made it. So great. We have 42 images for Charmander, 40 images for Pikachu, and 41 images for Bulbasaur in our testing data set. And I'm also going to provide this code in the chat box. So I hope you guys remember that we installed this Keras data preprocessing library, and now we are going to import it. So from Keras dot, Keras underscore preprocessing, import image. Yes, Cabway, actually, I changed this. Can you see this? I'm highlighting. I changed it from can you see this? I'm highlighting this part. I have changed the path in the path line. You can see in the second line, I changed from train to test. So I changed, it was initially train, but now it's test. You got it? Great. So I'll also provide this code. And now, now we are done with our visualization. What we want to do is we want to store our data set in a in an array, or we can say in a list. So what we want to do is we first we will initialize some empty sorry, train data and train labels. I forgot to mention. And I'm also going to provide this code. So what we want to do is we want to store our training data, basically our images in this list, and we also want to label that data set. So we want to know, uh, actually, yes, you can use it, but because it's a beginner level bootcamp, so we are not using it because Packaret is an auto ML library, and we just wanted to introduce you guys to ML ops yesterday. You can actually use Packaret here, but we have you have to use some other libraries also with it, and I guess that would be quite hectic for you guys to understand. So what we want to do next is for category, category in our classes. So for for Charmander in our classes, for Pikachu in our classes, for Bulbasaur in our classes, what we want to do, we want to get the path, right? So it's images slash train slash and what would be category. Pikachu. And then we got so in this line we are getting the path to our image, and next what we want to do is for image underscore name in our os dot list directory we want of folder, right? So for image name, so our image name is something like, I guess it was in integers. So this, so for 296 in this, I guess the path, what we want to do, we want to get the image path, and it is quest dot path dot join folder, and our img name image, sorry, and we want to store our image now. So what we will do, we will load our image using this image library that we just imported, and it is going to be image dot load image img path, and the target size it should be 100 comma 100. So what we want, uh, um, uh, I'll just get it here. So we want to get our target size to 100 by 100. So we have our images of varying size, right? Sometimes we have 256 by 256 image. Sometimes we have 300 by 300 size image, right? But we do not want this irregularity in our dataset. We want our dataset to have only a single size. That's why we are specifying that while reading our image, I want the library to just reshape the image from 256 or whatever the size it has to 100 comma 100. So the image that are trained data is going to store will have 100 at its width and 100 at its column, and so we have successfully read our image, and what we want to do now is we want to convert it into an array. So our image array is image dot img to array. Okay, so great, collab wants to help us, and we pass our image. So how am I writing this function? You can just go to the documentation of keras preprocessing, and you'll get it there. So what we will do, train data dot append. What I want to append is I want to append image array, and at the same time I also want to append our category. So you can write some print statements over here so that you can visualize what this code cell is exactly trying to do. I'll just summarize it once again. For Pikachu, Charmander, and Bulbasaur in our classes, what I want to do is I want to get the path to these folders, and when I got the path to, so in this first line we are going moving till here, till train folder. Then what we want to do is we want to go to these folder, right? We want to visit each of these folder. So consider that we want to move to our Pikachu folder. So what we'll do for Pikachu in our folder, what we want to do is we want to get the image name right? So that's what this third line is trying to do. And since we got the path to our image, what I want to do is I want to read that image. So we are reading this using this, just close it here. So we are going to read our image, convert it into array, and append, I mean store it in the training data list. And I guess it will take some time. Till then, you guys can also do the same. It it did run quite fast. So guys, am I going too fast or should I wait for you? Okay, Sri, you are just flash. Thanks for the acknowledgement. What about everyone else? Okay, Cabwe, okay. Cabwe, I have also provided the code in the chat box. I guess I'll just pin it again. I'll tag you along with it. So it's Cabwe, right? Okay, Priyanshu did it. What about others? Where is Surya? Okay, Surya also did it. I guess I'll just wait for few minutes, and if Cabwe is done or everyone else is done. Okay, Cabwe did it. Sure, Bontu. So great, great. So Bontu, what we are doing today is we are going to build a Pokemon classification model today. And you already, I guess you also attended our first lecture, which was taken by Atharvo, and he talked about image classification out there, right? Do you remember? He classified the images into three types. Uh, it was actually Charmander, Pikachu, and Bulbasaur. That's what we are going to implement today. We are going to develop a deep learning model, a neural networks model, and I hope you got it till here. Next, what I want to check is what is the how many total images do I have? So train underscore data. Great. So we have 304 training images. I guess that's what these three values sum up over here. Yes, it's 304 images. So guys, can kindly acknowledge me that yours is saying 7. I guess you messed up somewhere, Capway. Can you write this code again? I'll wait for you, I guess. Okay. Actually, it's 8:20. So Capway, what you can do is you can post your code, or you can just contact one of our team members. I guess Atharvo is there. Okay, Atharva, can you look into it? Okay, Sri got exactly 304. Yes, Atharva, can you just look into his code and I guess I'll have to move on cause it's already running late. Sorry, Capbe, for that. So next, what we want to do is we want to convert our data set into NumPy arrays. Now, what is a difference between a normal array and a NumPy array? It's quite complex, but I'll say it simply that we want to convert our Python arrays into C++ arrays. So do you guys know what is a CPP? Oh, I accidentally ran it. Sri is aware. What about the rest? And there you go. There we have converted our images into NumPy arrays. Is code in the chat box. Now, what we want to do is we want to reshape our array, reshape each of our image into some specified dimension that we will fit to our model. So what we want to do is we want to reshape. So what we'll tell Python is that, hey Python, just take my train data and reshape it. But Python asks us a question, what dimensions do you want? So I want the dimension that it should contain the 304 and the, I guess, 30,000. And I'll also share this. And when you run it, I guess it will be great. So you can see that we have successfully changed our shape from 304 comma blank to 304 comma 30,000. So guys, did you got the same shape of the training data? Sri says done. What about the others? Bontu, were you able to follow? And where are others? Janvi says done. Okay, Janvi is back. There is, okay. Bontu says yes. Pushkar, Surya, I'm waiting for you guys. And I hope that Cabways error also got solved. Now what we want to do is we want to convert our category to labels. To label. But how are we going to do that? Firstly we will make some dictionary. Okay, thanks. Thank you for being with here, Cabway. Actually, uh, uh, I guess there someone accidentally unmuted their mic. Can you just so Using this category to label, what we want to do is we want to convert these the directories, right? The Pikachu into 0, Charmander into 1, and Bulbasaur into 2. So, right, we cannot perform mathematical operations on our what we can say string values, right? We cannot perform mathematical operation on this word Pikachu, but we can perform mathematical operations on these numbers 0, 1, and 2. That's what we are going to do. And so this is before training the model. We are going to feed category to label, and after training the model, what we want to do is we want to convert those label back into category, right? So what I want to do is if it's 0, convert it into Pikachu. Oh, I'm so terrible with these spellings. And if it's 1, then convert it into Charmander. And if it's 2, convert it into Bulbasaur. Right? So we are going to feed this into the model, and we are going to extract this from the model. After it makes some predictions, right? And I'm also going to provide this code in the chat box. Right? So it ran without errors. Now what happens is that these are some integer values, but what we want to do is we also want to convert it into numpy arrays, so as to speed up our calculations. So and also as these are labels to training data, what we want to do is we want to convert our training data labels into these values 0, 1, and 2. So what we want to do is train labels should be converted into numpy array. But what are these labels? So these are category to label and another box for label or like sorry, there was some background noise actually for label in our training labels. So using this line, what we are doing is we are converting each of the training labels already present in our training label to integer values, these 0, 1, and 2. Okay, key error, Bulbasaur. Okay, okay. Just a spelling mistake. So I'll just provide these two code cells again because there was some spelling error, right? So guys, kindly acknowledge me that you got it till here and you have successfully coded till here. I guess everyone is coding. Janvi says done. Three says done. These two guys are very enthusiastic. Okay, Bonsu says it's done. Also done. And I guess Pushkar is left somewhere. Now, what we want to do is we want to convert these training labels into categorical values. Okay, Capbase is also back. Great. So Keras dot utils. I want to import the two categorical library. So these two categorical library, what we will do, it will convert the training labels into some 01 values, 001 or 010 or 100 values. So as it can represent these 01 and 2. So 0 will be converted into 100, 1 will be converted into 010, and Bulbasaur will be, these two will be converted into uh, 001. So how are we going to do that? We are going to apply these two categorical function on our training labels. So categorical on train labels, right? And great. So thank God it didn't give an error. There you go. And when you see these training labels, when you just want to visualize it, you'll see that what I said was, so these are Charmander images. We have labeled our, I'll just show it. So first was our, I guess it was Charmander Pikachu. So our first image is our Pikachu's image because it's 010. Then from here we have Charmander images, and at the bottom we have Bulbasaur images. So that was what this function trying to do. I'll just close this output. Next, so now we are going to build our model. But for before building, we will be importing some of the libraries so as to help us for building them. So from Keras, sorry, Keras dot layers, what I want to do, I want to import which layer? Dense layer. And next, what I want to do is I want to import another important function that is sequential. So dense basically represents our each of the layers in our data in our model. So as you saw earlier when Athar was explaining, he showed you three type of layer, right? Input layer, hidden layer, and output layer. So this input layer is one dense layer. This one hidden layer. Okay, I'll just show it. So this one layer, this input layer is one dense layer. This is also a dense layer, and this is also a dense layer, and this is also a dense layer. And why are we using sequential? So sequential, what it will do, it will hold all of these dense layers and make up our model, right? So these four layers make up our model, and these, as you can see that it is a sequential model, right? One layer is appearing one after another. I hope you got the intuition what I was trying to convey. And next, what we want to do is we want to extract the number of features. So features is equals to string underscore data dot shape and the first axis. So I'll provide these two codes over here. Oops, I accidental steps. So guys, are you guys ready to build a model? Or from Kira short live divide the layers from Kira sample. It will hold all these layers and make up the sequence. Yes, that's right, Siri. Oh, sorry, Sri. Okay. Uh, so guys, are you guys excited? Because we are going to define a model now. How many layers it is going to contain? How many neurons it is going to contain? What will be the input? What will be the output? Are you guys here? Okay, great. So let's define our model. So we want our model to be sequential, right? Sequential. Uh, at this, then we have initialized an empty, a neural network without any neurons, without any uh, layer. And now what we will do, we will add some layers and neurons to it. So how are we going to do? We are going to use model dot add function. And as I already said, we are going to use dense layers. So we are going to use dense layers, and then we have number of units. So units represent the number of neurons we want in our layer. So in our first layer, we want 512 neurons. So as I said earlier, and you guys, as I asked earlier, and you guys answered it correctly, the equation of line. So in our first layer, we are going to compute the equation of line 512 times. And what will be the activation function? If I commit some mistake, please correct me. Spelling mistake always happen. Next, I want to specify the input shape in underscore shape, and it is features comma one, I guess. No, only features. Oh, yeah, okay, okay. I got that. Great. So we have added our first layer into the model, and you can use model dot summary to see how many. Okay, bound method. Oh, sorry, we haven't compiled our model, right? So I guess we'll first build up some layers. So I'm going to copy this from here to here. And next, what we want to do is we want to reduce the number of neurons in our next layer. And we don't want to specify the input shape. So this was our input layer. Now we have our first hidden layer. Now we also want to add another hidden layer, which will consist of how many neurons? 128. So as you can see, these neurons are exactly half of the preceding layer, right? But most of the time, what we will do, we will sometimes increase the number of neurons, sometimes decrease the number of neurons. Uh, the choice of neurons in each layer depends on the problem you are solving. We cannot actually predict the number of neurons or number of layers that will be best fitting our data set. So I guess I answered Yash question when he asked the how to get the correct number of neurons. Next, we will be adding third hidden layer, which will consist 64 neurons. And finally, our output layer that will be model dot add, and it is also a dense layer. And how many outputs do we have, guys? Can I get a quick acknowledgement? How many outputs we have, right? How many classes do we have? Can you guys tell me quickly? No, Bonzo, we have three. After some time, neurons stop learning. No, so can we use high number of neurons? Okay, so that's a very core question you asked there, Janvi. So, if a neuron stops learning, the whole neural network will fail. So it's a problem that is not in the scope of this bootcamp. So I'm sorry, but I can't answer it right now. But you can connect me on LinkedIn, so I'll provide the answer over there. Next, so you guys got it correct. It was three, and Athavi is also here. Great. So we have three outputs, and which activation we are going to use? Athavi also already told that it was soft match, right? So why are we using softmax? Because softmax provides output in only 0 and 1. So what it will do in this, it will take any random value between minus infinity and infinity, and it will just summarize those values into 0 and 1 only. So I guess we have built our model, and now we want to compile it. So why are we compiling it? I'll just tell you, but let me just first write the code. So firstly, we will specify the optimizer. It is Adam and loss go categorical. I guess it was cross entropy. And the metrics should be accuracy, I guess. So okay, I have to do this so you guys can clearly see what I'm coding. So So why are we using this compile method? Because we successfully built our neural network, but there are some other things that we have to specify in our model, such as the optimizer that we are going to use. It is Adam. So what is this optimizer? Basically, it will speed up our calculation. Then we also want to specify the loss function. So there are many loss functions available there, and I already told you one of the loss function. It was mean squared error, I guess, in the linear regression lecture. Then we want to specify the accuracy. Thank Atharva for sharing my ID. That's a great help. And then run this code. Okay, so we have successfully compiled our model, and we can write model.summary bound method model.summary I guess I did something wrong over there. Oh, was this missing? Oh, so you can see, guys, we have this much layers. So there are four layers out. Sorry, there are five layers. First layer is our input layer that consists of 512 neurons. Then we have our first hidden layer that contains 256. Then we have our second hidden layer, 128 neurons, and then we have our third hidden layer with 64 neurons. And at the last, we have, okay, so Yash is asking what is optimizer. So optimizers, just Cabby, I'll just quickly share it in the chat box so you can see for it. I'll share the combined code so that just a second. I'll have to plug in my laptop. And where is the chat box? Okay, here it is. So there you go, Capway. Okay, I'll do that. I'll So guys, can you tell me that how many layers do we have and how many layers do you got? I guess everyone else is coding right there. Yes, you are. Yes, you are right, but partially because we also have one input layer, right? So there is one input layer, three hidden layers, and one output layer. Yes, that's right. Yep. So, Cafe, are you done? What is param? Where are you seeing it? Okay. Okay, so you are seeing it in the summary. I'll tell Sri. Mm, Let me get an acknowledgement from Cafe that he's done, that he caught up us till here. Okay, okay, Cafe. I'll have to move. So, uh, Sri, Atharva told that we are computing weights and biases, right? So these are the parameters. So as you can see, since our first layer contained 512 neurons, it contains this much amount of weights and biases present in here. So what our neural network is trying to do, it is trying to learn this much number of values such that it can correctly classify our images into the categories, right? So did you got it? Okay. Uh, Now we have defined our model. So what will be next? We are going to train our model, right? So model dot fit on our train data. and the data also contains some labels, right? So those were train labels. And what we want to do is we want to specify our batch size to 32 and the number of epochs, the number of iterations basically, number of iterations to 50. So what is this batch size? So uh, after every iteration, it is going to consider only 32 images. Okay. And run this cell, the model will start running, sorry, training. Okay. And it is going to take some time. And you guys can see that the accuracy keeps on increasing after every iteration here. I'll keep my screen here so you can just do it. Okay, so it's taking its time and on how much? Okay, so we are on our 30th iteration. Guys, how on what iteration you are? And can you guys acknowledge me that you have followed me till here and your model is on training? Yes, so do you remember, Sri? I told in my lecture that the linear regression, what gradient descent was trying to do, it was trying to reduce the loss and increase the accuracy, right? That's what our neural network is trying to do here. It is trying to minimize the loss so that we can increase our accuracy. Great. Atharva's model has already been trained. What about the others? Okay, so I've successfully trained my model, right? So can I get quick acknowledgement that you guys also did it, or if it's on training, just acknowledge me. Janvi says done. Okay, Sri is at 40. And where are others? I guess there was Pushkar, Surya, Yash, and also Bontu. Okay, Bontu is here. Bontu's training is done. Sri, Sri says done. Okay, right. Great. Cadway, did you reach here? Uh, Okay, that's great, Sri. So the accuracy is actually 94.08%. Cadway, are you still facing any issues? I have reached, but mine is still behind. I will fix it when we are done. Okay, great. So we have trained our model. Now, do you guys want to predict some Pokemon, right? Do you want to give interact with our model? Yes. So uh, this time, what we will do, we are not going to use an image from a data set, but we are going to use a random image from the internet. So we have three classes, right? So it was Charmander, Bulbasaur, and Pikachu. Now what we will do? Go on anywhere and search for Pikachu. I guess we are going to. I'm going to use the Pikachu and just download any image. I'm going to use this image. Right? You can just use any image of your of the bat and just save that image. Should be Pikachu. So download any random image from the internet and come back to the collab. As soon as you download and the download is completed, upload the image using this icon over here. I'll show it. So upload an image using this icon. I'll erase it once. Close. So I'm going to upload the image that I just downloaded and open it. Ignore this warning. Okay, great. So did you guys got it till here? Did you guys uploaded an image in the collab runtime? So I hope you guys are also performing with me and okay, great. Captain says he's done. Everyone else, did you guys got it till here? And did you perform till here? Okay, so as we have some very limited time now, what we will do, we will store this the path to this image into so just go on to Pikachu and uh, on the image file you uploaded, click on the these three dot and you will see uh, copy path option. Come back or in the cell and just paste the value that you copied right now and then what I'll do, I want to read that image, right? Firstly, we got the path. Now we will, it's all right, Sri. You can take images. Okay, Janvi says she is done. Okay. It's fine, Sri. You can use any format. Any extension would work. Even if it's JPEG or JPG or even WebP. We will be doing is load image. The path to the image is test underscore image comma the target size was 100 comma 100. Next, after reading the image, what we were doing, we were converting it into array. So image dot to image to array, and it is going to convert the image. So we passed our image into the next function, and we want to visualize the shape of the image. So image dot shape, and there you go. We have successfully shaped our image into ocean. Okay, so we have reshaped our image into 100 with three channels. They are RGB. So I'll copy this code and paste it in the chat box. Make sure you specify the path to the image correctly. I'll repeat it once again. Upload your image and you will see your image around here. Click on these three dots and you will see copy path option. Okay. Sri says done. That's great, Chanvi. Okay. And then copy the path and come back in this cell, paste it here. Right. Then for a quick recap, to I want to show the image, right? So I'll show I'm show and what I want to show is I want to image dot as type integer. So and there you go. So I had downloaded this similar image, right? So these two look quite similar, right? And I also provide the code. Don't forget this colon or semicolon over here because it will definitely give you an error. Oh, that's great, Bonzo. That's great. Now, what we will do is we will reshape it, right? So we trained our model on uh, an image with that has 30,000 channels, right? So what we are going to do is image and I want to reshape it, right? So reshape it into 1 comma 30,000. I'll provide this code. Now what I want to do is I want to use my model to predict model dot using the model dot predict function and on what we are predicting on the image we are predicting and we are also going to use the argmax function. So what is this function trying to do? So our model will predict values between 00111 or some values higher than that. We don't want that, right? We want the maximum value. That's why we are using the argmax function over here. And as soon as you do that, okay, great. So we have successfully predicted, we have successfully fitted this image on our model. Now we also want to get the prediction from the model. So I'll just extract the prediction from label to category model dot predict img argmax and you can see this prediction. Okay. So I want you guys to run this cell on your own. I'm not going to show you the output of this. Okay, so I provided only will be reshaped. And I'm waiting for you guys to quickly acknowledge me that what output did you got? Was it correct or incorrect? Priyanshu says done. So Priyanshu, did you got the correct output? Okay. Asha was here. She says Charmander. Cafe is done. Janvi also got Pikachu. Sri got Pikachu. Sri says correct output. Great. So Priyanshu, what Pokemon did you use and what output did you got? Okay, Pikachu. Born through it is saying Charmander. So did you use this argmax function and the image dot reshape correctly? Or because accidentally you might not have ran this cell. Yeah, that's important, right? Thank you for the acknowledgement, Atharva. Where are the others? Where is Surya? And I guess there were more folks before. So we are at the end, and so it correctly predicted Pikachu, right? So what next you can do, guys? You can go to internet, pick up any random image, and as you all also know that how to follow the other steps. So congratulations, you have successfully built a Pokemon classification model. So how was the model, guys? Uh, Okay, thank you, Cap says. That's great. Okay, so she says that model was exciting. So, okay, thank you for the feedback. It really means a lot. So, guys, uh, I'm I'm near the end, and the bootcamp is also near the end. So, I'll uh, give the rights to Athava, and hope Athava is here. Athava,
Yeah, I'm here.
I'm here. So you are good to go.
Great. So yeah, hey, hello folks. Like when I've just completed the Azure Notebook portion. Someone said that it's just a drop of an ocean. So do you want to learn the entire ocean, or do you want to experience the ocean? How big it is? Can I know in the chat box quickly? Yeah, somebody just commented out also. So can I know? Do you want to dive deep into the ocean? I have something for you. That's fine. Just let me know in the chat box. Yeah. So like this is the stuff which was a Azure notebook. It was quite similar to the Google Colab. So it's nothing different there. You are just getting a good computation power. For this, you will require some credits, and that you can get it from free. That is from GitHub Student Developer Pack. Like it is there. It is there for all. What you need is just a mail ID of your college, or iCard will work. And if you are not a student, like if you are not a student, then also it's fine. You can get free 100 credits. Yeah, Bontu has it. So Bontu, there are also Azure credits involved in it, right? You know that, I hope. Okay, yeah, Cabbe. Like I will put this in the chat box. Like yeah, this is the GitHub Student Developer Pack. You just need to get it approved. Yeah, no need to worry. Like there are free Azure credits available for you. Like if you just move on Microsoft Azure, and you just search it yeah, on the Azure, I guess, not for students. Yeah. Okay. Sorry, that was by default. I haven't done it. Yeah. So you can just search it off, and once you go for it and just try logging in, then you will get free credits and you are good to go. You are good to use that. Fine. Otherwise, other resources are already available, like Collab and all. So my thing was, somebody said that they want to learn all this stuff, right? Yeah, you can submit this. So if you want to learn new stuff, how to use this Azure notebooks or anything new, so you can just go to Microsoft Learn. It actually provides a lot many resources available for you. So I will just cut paste the link about here. Yeah. So once you move out here, you may get anything, whatever you want. Suppose you want to start with DevOps. Like it's a really cool and amazing field. We also had a session recently. Yeah, Gabby, you can go, you can get more stuff from that link. But the only thing is it is only for students. So yeah, you will have to maintain that criteria. You will get free domain name, free servers, and you will also get many stuff. Like there are many benefits available in the student developer pack. So yeah, this is the thing. And here you can get many resources from here. You can also complete your certifications and all. So yeah, like if you just move to certification portion, so you may see. So Microsoft certifications are there for administrator, AI engineer, app maker, and it is a learning path which you can entirely go through, right? Yeah, so you can you can just okay, so you missed out the session, right? So it was in offline mode, Shri. Like it was entirely in offline mode. We haven't done that session in online mode, and I guess there somewhere around 80 to 90 folks joined in, and that was really a good, amazing experience, right? So yeah, so you may just use this certifications. You may do that, and you may learn a lot more things from this. And actually, it is way too good, and the paths are also quite good and properly arranged. So I guess we are almost at the end. Hope you all guys learned a lot from these sessions. And yeah, that's all. I guess. Do we have Pal here? Hello.
Yes, yes, I'm here.
Yeah. So yeah, that's all. Thank you guys. Hope we will meet in the upcoming sessions. That's all from my side. We may conclude.
So, folks, one link is shared in the chat box. I request to all the participants to fill it for your certifications. After this, certifications will be all yours. Form link is pinned. Fill this out as soon as possible. On behalf of Jarvis Forum and Microsoft Learn Student Ambassador, I would like to extend my heartfelt gratitude to each and every one of you for being consistent with us till here and for making this machine learning bootcamp a resounding success. Thank you, everyone.